everyone. We are delighted to have you join us to explore how AI can enhance smart contract security. So in this sharing, we will examine the optimization that can be made during development phase and specifying the specific improvement that AI can bring. So also, we will talk about the current potential limitation in this field. Finally, we will share the contribution we hope our research can bring to the security industry. Okay, so next slide. Okay, before we begin our presentation, let's have a quick, brief self-introduction. I'm Daky. Currently, I'm in charge of Web3 product and development team at OneSavie lab, and I'm also the member of DeFi Labs. So if you have any question about today's sharing, or any thought about the open source project we will mention later, feel free to direct message me on Twitter.
Hi, I'm Alice. Currently a security research engineer at OneSavie Lab, and also a member of the OPS team and white hat at DeFi Labs. My primary research focuses on Web3 security. Here is the outline of today's sharing. In the background section, we will introduce the current state of the commonly used tools and the stage at which AI can assist us in improving our work. Next, we will introduce our open source project, Bastet. In the introduction section, we will briefly explain the project structure, how we select targets. And in the methodology section, we will introduce the components of the workflow in Bastet. And finally, in the conclusion, we will share what we found during the experimental process. Okay, let's get started. DeFi applications are becoming increasingly diverse, and with the growing awareness of security, the volume of security audits before contract deployment is also increasingly growing, along with a growing variety of audit platforms and related services. Against this backdrop, we hope to work with the power of the community to drive the ecosystem security of the Web3 industry. We want to more reliable identify vulnerabilities that are not easily detected by common tools, but frequently occur, reduce the back and forth cost of audit report writing and developer fix, and ensure these common vulnerabilities can be addressed during the development phase. As a white hat involved in competitive audit platforms, when seeing a new code base of a certain type of DeFi, many common bug lists for that type immediately come to my mind. However, many common bugs continue to repeatedly appear in codebase, even up until now. When a protocol integrates with Uniswap, most people will first look for issues related to improper slippage settings. When the protocol is a vault, we will first check for the possibility of the first deposit inflation. If the README mentions that it needs to compile with a certain EIP, we will review the EIP documentation and conduct a detailed review of the codebase. These issues are almost like old friends to us. When we conduct code reviews, our goal is to focus on enhancing security coverage, identifying all problematic code snippets, and writing detailed reports for these bugs. Even if these issues are just like low-hanging fruits, they are just like your bodies. When you audit a specific type of protocol, they always show up and knock at your door, partying in your audit report. However, whether it's a private audit or a competition, it is always limited by the allocation of resources. The most valuable part is, of course, the cost of time, as the execution of the project is time limited. We must strive to uncover as many issues as possible within the limited time and resources. More precisely, we need to focus on identifying higher quality problems. Assuming a more complete development lifecycle is divided as follows: development, testing, auditing, continual monitoring, and incident response. The most suitable stage for improvement would be during the testing to auditing phase. Identify these common issues and fix them. This can reduce researchers from writing reports on repetitive issues and help the project team avoid pitfalls during the development phase. In current smart contract audits, the most common tools are static analyzers, such as Lisa, which can be integrated into CI/CD environment. Phonalizer is used in the well-known competition audit platform like C4. These static analyzers mostly use AST or RegEd methods to detect common vulnerabilities. They perform static code scanning and cannot fully understand the execution of logic of the code. When the contract is written in another programming language, they are also unable to identify issues with the same root codes. They are not effective at detecting some common vulnerabilities that involve logic. Based on the background mentioned above, and we think kids are adorable, our open source project, Bastet, was born. We will use the slippage vulnerability as a case study and introduce the methodology of our project, Bastet, including the workflow design and the results of our preliminary experiments. Our open source project Bastet mainly consists of two parts. First is vulnerability dataset plus AI audit benchmark, and second is AI vulnerability identification process. Let's have a sneak peek of our user scenarios. The users can use CLI to scan the smart contract code base or evaluate the accuracy of an AI assessment workflow. If you choose to scan, you can place the contract in the specified folder. There are many optimized rules available in the workflow to use, and the output will be a report. If you choose to evaluate, you can select a workflow or import a customized workflow. The corresponding dataset for the vulnerability will be used, and the output will be the accuracy results. How do we select our targets? Our vulnerability selection focuses on common vulnerabilities that are difficult to maintain with static analyzers. These vulnerabilities are often classified as medium to high risk in audit competitions or platforms and can lead to losses. By designing corresponding vulnerability detection and enhancing AI's accuracy in vulnerability identification, we aim to effectively optimize the security lifecycle management from development to auditing and subsequent monitoring. This workflow contains some essential elements. First is knowledge. AI is highly skilled in understanding code and identifying subtle syntax errors. Before using AI to help us identify a specific type of vulnerability, the knowledge of the vulnerability needs to be prepared. Once the knowledge is prepared, we need to create clear prompts to guide AI in detecting vulnerabilities. The design of these prompts will directly impact the accuracy of vulnerability detection. And finally, in the validation part, The purpose of validation is to ensure the accuracy and effectiveness of the detection results. We use different test data to calculate and evaluate the detection results. Okay, let's now introduce the vulnerability case for today's sharing, slippage. Slippage refers to the differences between the expected price of a transaction and the actual price at which the transaction is executed. Using Uniswap as an example, the amount of assets you can receive from a swap is calculated based on the reserve of the two assets and a formula. However, the amount of assets you expect to receive, the time of the swap, may differ from the actual amount you get. This is because the transaction may not be executed immediately after submission. If the market changes during the transaction execution, it can lead to a different result than expected. If there is no slippage check, an EEV can monitor transactions and perform a sandwich attack before and after the transaction, profiting from price fluctuations. The user will receive fewer assets than expected. Before we dive into introducing prompt engineering technique, let's assume we want to use a static analyzer to search for this type of vulnerability. How can we go about it? In the case of Uniswap v2, we would first use find all to search of all functions where slippage could potentially occur, such as swap exact tokens for tokens, swap exact ETH for tokens, add liquidity, remove liquidity, and so on. In the case of Uniswap v3, there are functions such as decrease liquidity in half, increase liquidity current range, swap exact output single, swap exact input multi-hop, and so on. And next, we will identify where parameters like median amount are located within the functions, and at which position they appear in the parameters. Then, for each type of improper slippage setting scenario, we need to write a condition statement to perform the check. What are the challenges of doing this? There are many protocols that perform swaps, such as balancer, curve, and other. The function names for implementing swaps vary across protocols, and the parameters and their position for setting slippage are also completely different. Moreover, these condition statements encounter the same issues, but they do not work with code snippets written in other syntax. This makes it difficult for us to maintain and update these rules.
Okay, so now we move to the methodology part. I forgot. Yeah. So if we want to use AI to assist us to identify vulnerability, so what method are we using? So let's give an example about how a human brain learns to recognize cats. So you can see on the screen, we have the knowledge base. Suppose today we use this passage to describe the appearance of a cat. So here's the definition, right? We can take a look at it quickly, since later we will have a section for everyone to join. Yeah. So you have two images. You never see a cat or a dog before, and now follow the guideline to recognize cat image. Are you ready? So let's go to the next. So AI might think, so image like 3, 4, and 6 are cats. Because in the knowledge base, we mentioned cats have upright ears and sharp claws. Yeah. So everybody want to try? So if you think image number 1 is a cat, you raise your hand. Okay, 3, 2, 1. Number 1 is a cat. Okay, number 2, you think is a cat. Okay, 3, and 4, 5, 6. Okay, so let's go to the next slide and let's look at the answer. This one. Okay, so the real answer is image 1, 2, and 3. It's a cat. Yeah. So this example shows that simply having a paragraph of text to describe a cat is not enough. Should be very limited to its effectiveness for use AI to recognize a cat. So if you want to teach me how to recognize a new species, and give me some example, plus the description will be very helpful. Yeah. So the learning method is very similar to how AI learn new knowledge. Therefore, we adopt the COT approach. The box you can see here contain the whole prompts. And the red part is the question to be answered by AI. And the blue part, step here, represent the COT steps. By using the COT, the reasoning ability of large language model can be improved. So if we directly feed knowledge to AI, the recognition result will be poor. And by breaking down the reasoning process into multi-steps, we help the model to think step by step to solve the problem. So this reasoning process are close related to the root cause of the vulnerabilities. Yeah. Okay, so here is the prompt structure we designed, which includes solve plus for identifying vulnerabilities. We have AI to analyze each function according to the specific step and detail the solve process in both contract contents, vulnerabilities, and incorrect implement examples. Finally, the report is generated based on the common report format, presenting the detection rules. Okay, so next slide. So here you can see the output of bodies using one of our contract in the data set with improper slippage parameter settings. The general report is shown in the image. This report includes one sentence summary of the vulnerability and severity, followed by vulnerability details, which contains the code snip you can see here, and describe them in the issue. The report points out the function where the issue occurred and explain why. And also the last, the recommendation part provides suggestion for fixing the issue. And also, when we talk about accuracy, right, let's get started also with an example to show how we calculate accuracy of AI recognition. So in the diagram, you can see we use a model to identify which image contains the dog. It's a dog, right? So the left part of the square represents a contract with vulnerability, which we symbolize it as a dog. Yeah, and the right part, the right side, represents a contract without vulnerabilities. So we symbolize it by cat. And the circle in the middle is the result that AI recognized. So with this formula, we can calculate like the correct classification is here. We have 5 dogs plus here we have 7 cats. So it's 12 divided by the total number of images, 22, is about 54% accuracy. So our goal of this workflow is to increase the accuracy rate, but also minimize the false positive. Because the false positive might significantly increase manual validation cost. Okay. Okay, so here is the result that the slippage meaning among our workflow provide in this case study. We use our detection tool to evaluate. Then we can have the result, true positive 12, true negative 27, false part 2, and false negative 5. So the accuracy is about 85% of our workflow for this showcase. And also, the result is what we want to see. We want to maximize the accuracy of our detection. And our focus is on reducing the false positive. We refer to no more contrast being incorrect flagged as vulnerable contrast. This is important because during the development and testing phase, as a larger number of false positive can lead to significant human cost increase.
I would like to pose some questions and share the points we have discovered so far from our experiments. First, can BuzzStat one day replace human researchers? This question is very sharp, but I believe this applies to other fields as well. The purpose of tool is to assist us in completing tasks more easily. The purpose of BuzzStat's existence is to allow researchers to focus more on identifying systematic risk, logic errors, integration issues, and other types of vulnerabilities. AI technology is moving fast and constantly being updated. We believe that as an assistant, it will keep getting better. BuzzStat is a public nonprofit project. How to make it more powerful? First is data. We need more vulnerable smart contracts and attack vector ideas. And second is knowledge base. Needs more quality content as sources for the knowledge base. We have also benefited from the transmission of these knowledges. And last, methodology. We need more AI engineers to propose better AI identification methods. We believe that all of these are open source. Everyone can benefit from them. And the last question, is BuzzStat limited by the knowledge base? What if there are unknown vulnerabilities in the code base? Currently, BuzzStat is also experimenting with identifying vulnerabilities that are not in the knowledge base. We have partnered with DeFi Hack Labs and the Taiji Audit Group and have made some preliminary progress during the auditing process. BuzzStat has already identified valid findings in every audit, including high and medium severity issues. It is particularly skilled at identifying subtle details and implementation errors in code, which allowed us to detect potential vulnerabilities that might otherwise be overlooked. We believe that they have potential for development in helping researchers initially address and eliminate such issues.
So let's summarize today's sharing. So we have two key takeaways for you about BuzzStat. The first is data set and evaluation tool. By combining this together, you can easily learn from the vulnerability database and test the accuracy of the tool. The second is the AI workflow. You can easily modify prompts or add any custom feature you need. The GUI tool we used also provides flexible workflow toggle, and you can swap the model as you want.
The final part is 3 minutes DeFi Hack Labs time. Give a sneak peek of the platform that DeFi Hack Labs will launch next. Recently, DeFi Hack Labs has teamed up with Slowmist and ScanSniffer to create a public good Web3 anti-phishing training platform, supported by an Ethereum funding grant. As a member of DeFi Hack Labs, I have learned a lot and benefit greatly from this community. I am deeply grateful to all the researchers who selflessly contribute to the advancement of the Web3 security field. Each person's focus on security is a driving force for the progress of the industry. We also aspire to uphold this spirit, gathering everyone's intelligence to make Web3 more secure. Together, strong. You can follow our X. We will continue to update the latest Web3 knowledges and activities on it. Thank you all for your time today. Start our project now.
Okay. Great talk. Yeah, less hallucination and more protection. It's a great way to use AI. So we have a couple minutes for questions. Anyone has questions? Hey, do you have a microphone? Yeah, he goes first.
So you mentioned the code is open source. I'm wondering if the knowledge base is also open source. And second question, sorry. Have you guys tried fine-tuning the model, or are you using a generalized model?
Okay, so the first question, we open source all of the code and also the data set and also the workflow. So everything is open source. You can git clone it and do whatever you want. Yeah. So the second question is, do we fine-tune the model? Now we use GPT-4 or Mini to do the showcase for slippage vulnerabilities. So you can swap the model for whatever you need. And for sure, in the future, we might think about if maybe the fine-tuning model can improve the accuracy. But at least now we have the evaluation tool. So everyone can know if you change the prompt, the result is you got is better or is even worse. Yeah.
Cool. Another question from this gentleman. Oh, okay, same question. Okay, cool. Another question from this one. Yeah.
Hi, I like the Uniswap examples you used because when we made the Uniswap v4 Cantina competition, there were hundreds of false positives that we got, and that was a massive manual cost to go through all of them. I was wondering if you used this fast step for any recent competitions or bug bounties and what your accuracy rate looks like on them.
We are now focused on knowledge-based identification. If the bug is not in our whitelist, we still experiment on it. Yeah.
Cool. We have 1 minute left. So if you have a short question, still can accommodate. Any questions? Okay, no. Then special thanks to Alice and Daky again. Thank you.